Good afternoon, everyone. Welcome to Concordia University's Force-Based, kind of a virtual edition, but thanks for joining us for today's event, Remote Sensing and Indigenous-led Nature-Based Solutions that address emissions and biodiversity targets with Camilo Alejo and Angela Kross. Now, this is part of the Loyola College for Diversity and Sustainability Across Disciplines conference we've been having here all week, and we would like to begin by acknowledging that Concordia University is located on unceded Indigenous lands in Tiohtià:ke, Montreal, and we respect the continued connections with the past, the present, and future in our ongoing relationships with Indigenous and other peoples within the Montreal community. And here at Force-Based, we work with our university community to help mobilize knowledge. We co-create daily activities that examine research questions and projects happening all across the university. And we're running today's event, unfortunately, as only a live stream to YouTube and via Zoom, thanks to some weather conditions happening here in Montreal. So if you're joining us on Zoom, just pop your questions into the chat and we'll work those in a little bit later on. Okay, it's very much my pleasure now to pass things over to co-director of the Loyola Sustainability Research Center and associate professor in geography, planning, and environment, Sarah Turner. Over to you.
Thanks, Doug. Welcome, everybody. It's really lovely to still be able to have this event despite the impending ice storm. This conference is in its third day, but it's in its ninth iteration of the Sustainability Across Disciplines Conference, which is organized and run by the Loyola Sustainability Research Center, the Loyola Center for Diversity and Sustainability, and this year, with co-sponsorship with the School of Health and Future Earth, and also with help from the Department of Geography, Planning and Environment. And also with so much of the legwork and other work for this conference done by Rebecca Titler. So thank you so much, Rebecca, for all of your work in putting together this conference. And thank you so much, Doug and Jax and everybody in Fourth Space for partnering with us again and making this a success despite the weather and as in the hybrid events we had before and in the upcoming days. There are still 2 days of conference after today, both in hybrid mode, hopefully, and out at Loyola campus as well. So check out the list of events that's coming up. There's a lot of exciting presentations and workshops to go to. So do have a look at the schedule, the conference schedule, which Rebecca will post or has just posted in the link. Yeah, there's a lot of really exciting events upcoming as well. This year, more than in past years, we're sort of located in a variety of different places. So be sure to check the campus and the room before you head off. But yeah. So I'm excited to be able to introduce Camilo Alejo Monroy, who's going to be, I guess, having in conversation with Dr. Angela Kross and Damon Matthews. Camilo is a postdoctoral fellow and interested in the interplay of land tenure and local values and Indigenous knowledge, and looking at climate change and biodiversity and geospatial perspectives. And he has been really a wonderful part of our department's community over the last few years. And Dr. Angela Kross is my colleague in the Department of Geography, Planning and Environment and is an expert in remote sensing. And Dr. Damon Matthews is also a colleague in our Department of Geography, Planning and Environment, and he's going to be facilitating the discussion today. So I will pass this over to you all, and yeah, thanks to everybody.
Great, thanks everyone for joining. So yeah, I'm mostly just going to, well, Sarah already introduced the speakers, but I'll pass it over shortly to Camilo for the first presentation. And then we'll have a little bit of a Q&A after both speakers have presented, and also field some questions from the audience. So yes, Camilo, if you're ready to go ahead.
Yeah, perfect. Thank you so much, Sarah. Thank you so much, Damon. Thank you, Rebecca, for the invitation. Let me just share my screen. Awesome. I hope it works for everyone. So thank you so much for having me. So today I'm going to talk about Indigenous-led nature-based solutions and how they can align climate and biodiversity targets. So as an introduction and probably self-publicity, the topic of my talk has been already published. You can check it out at Earth's Future. And so please follow up. I'll share my contact in the end of the presentation, but if you are interested, please follow up. I guess as a positionality statement to start my talk, I would like to say that I am a person from Bogota, Colombia. I have a mestizo heritage, as we say in Spanish. So very proud of my indigenous roots. And this is also a collaboration like with my supervisor, Professor Damon Matthews, and also the strategic advisor of the Assembly of First Nations, Dr. Graham Reed. Okay, so I guess as a broader context, this is part of a project named Equitable Futures for Nature-Based Solutions. And basically, we've been trying to explore the interface of sustainability, digital age, tools, and thinking about how those two interplay to inform policies and decision making, and we've been doing that across Canada. So today's presentation is about one of the case studies that fed and contributed to that larger research project. So first of all, so what do we mean? I'm going to talk about nature-based solutions. So what do I mean by that? So nature-based solutions are basically any ecosystem-based interventions. So you may think about conservation interventions such as declaring a protected area, or it could be restoration actions, or it could be management actions that in the end, they try to enhance nature, they try to work with nature. So that means maintaining biodiversity while trying to address other societal challenges besides like those directly related to biodiversity. So you may think about addressing climate change or disaster risk reduction or addressing economic issues, human health, and so on. So it's a really broad concept, but it has gained great traction in the past years. So now let me start making a case for indigenous-led nature-based solutions. Why should we talk about nature-based, indigenous-led nature-based solutions? So first of all, indigenous-led, approximately, we think that they cover at least 25% of the terrestrial surface, and they also overlap with a significant part of protected areas. So that is already a reason of why we should be thinking about indigenous-led nature-based solutions. We also need to think that when we in this broader concept of nature-based solutions, indigenous-led has some specificities, and we could think that indigenous-led nature-based solutions could be think of like as a way of thinking, as a way of interacting with nature, as a reciprocal way in which people might interact with their lands and waters. So that's how we could frame it, and I think it makes a case for indigenous-led nature-based solutions. So basically, what I'm trying to say is that we could think about indigenous knowledges as nature-based. Another reason to think about and analyze and explore the role of indigenous-led nature-based solutions comes because of what has been happening in the past 2 decades. And so we have seen slow, not so quick, but a steady increase in terms of policies and programs that have been aiming to support Indigenous-led initiatives. So you may think about protected conserved areas, you could think about Indigenous Guardians programs. So all this set of reasons, obviously the coverage, obviously the epistemology that emerges from Indigenous knowledge and the kind of relationship that is built with nature, and also all these policies, I think that makes a solid case to think about the role of Indigenous-led nature-based solutions. So what do we know so far about Indigenous-led nature-based solutions? So mostly, or most of the studies are from the tropics. And so we know that Indigenous-led nature-based solutions have been very effective in avoiding deforestation. They have also been effective in conserving carbon storage. So there's a role in terms of climate change mitigation. And it has also been shown that they have a key role in protecting intact ecosystems. So you could see it as a biodiversity dimension and impact of Indigenous-led nature-based solutions. So one of what I think is an important and relevant research gap is that Indigenous-led nature-based solutions, like we have explored their impact, but we haven't explored and understood sufficiently the role of governments and policies supporting Indigenous-led nature-based solutions. So specifically, what we wanted to see is how government support may impact Indigenous-led nature-based solutions in terms of climate, in terms of biodiversity, and also in terms of social outcomes. And our case was Canada. So Canada has witnessed in the past decade favorable policies and funding towards Indigenous-led initiatives, and that includes the establishment of Indigenous protected conserved areas on the one hand, and on the other hand, Indigenous Guardians programs that support Indigenous leadership, Indigenous stewardship, to monitor their lands and water, and also like cultural activities around stewardship. So you have those two kind of programs, and so that's what we wanted to explore and use as a case study. So how do we do it? So first of all, so we defined Indigenous lands in Canada, and basically we separated them in terms of those that got some funding in the past, like in a time frame of 5 years, starting from 2018, where Indigenous protected areas, some of them at least, were established, and also the Indigenous Guardians program. So we separated Indigenous lands in terms of, did they get funding from the government or they didn't? And then among those projects that received funding, we explored their descriptions, the way they were defined, and we used a kind of analysis called topic modeling to understand like what were the most common terms and if they were related and clustered in some way to give us a sense of what were the most important or general topics that came from Indigenous-led nature-based solutions projects descriptions. And to give us a sense not only about environmental outcomes, but also how the way they relate to social outcomes. We also brought protected areas. So think about federal and provincial protected areas, also private areas. And we use them as a counterfactual or as a way to compare the environmental impacts of Indigenous-led nature-based solutions. And so to do so, to compare them, we use something called confounders matching, which basically means is that we try to identify indigenous lands where indigenous-led nature-based solutions have been happening, and we try to compare them with equivalent locations in terms of socioeconomic pressures, in terms of the ecosystems where they are located, to find that kind of equivalent on the side of protected areas. And so we use general additive mix models after that as a way to assess two kinds of environmental outcomes. So first of all, effects on carbon storage. So we wanted to see if in indigenous lands we tried to see if there was more or less carbon in indigenous-led nature-based solutions after controlling for different confounding factors. We also did that in terms of biodiversity. So we compared the impacts of indigenous-led nature-based solutions relative to protected areas in terms of biodiversity. And we used an index that basically measures richness, rarity, and also ecological intactness. So that was our way to measure biodiversity. So let's go to the results. So this, what you're seeing now are the topic modeling results. So what you see on top are the three emerging topics that come from the most interrelated words that in turn came from project descriptions. So one topic is land governance, and you see all the words that came up from that topic. So you see concepts such as land, water, and stewardship. So the way we interpret that topic is that a significant part of projects, they conceive land governance in a way that is about stewardship, that is about management, but it also involves, you may see, for example, involves youth, research, and different local practices to execute or perform land governance across indigenous-led nature-based solutions funded by the government. The other emerging topic was climate change adaptation. So many, a significant part of projects, they talk about climate change, but what is interesting is that they always bring a youth component. So it's about monitoring the land, and it's about performing stewardship across lands and waters, but always trying to bring some intergenerational exchange that is bringing the youth up front to these initiatives. And the final emerging topic that we found across indigenous-led nature-based solutions was knowledge exchange. So many projects, they mention indigenous-led initiatives as an opportunity for training their communities. Is also an opportunity if it's training, there's also education. Again, the youth is training the youth, bringing the youth to these initiatives is again a key component. Especially you see a lot of elders having exchanges with the youth in this across this topic, and also you could call it Western indigenous knowledge exchange that was also part of this emerging topic. So overall, what we can say is that indigenous-led nature-based solution, they have yes, you could say yes, there's land governance, there's climate change adaptation, there's knowledge exchange, but I think the way is being brought by these initiatives is in a very holistic way. That's a way we could interpret these results. Then when we try to see the environmental outcomes of indigenous-led nature-based solutions, so as I mentioned, we tried to compare them to protected areas that had equivalent socioeconomic and environmental conditions. And so what I'm about to show you is comparing indigenous lands that got funding from the federal government and therefore are indigenous-led nature-based solutions. So that is the first piece of results that you are seeing. So basically, first of all, like the levels of carbon storage in indigenous lands that got funds from the federal government is very similar to protected areas that are in similar or equivalent socioeconomic and environmental conditions. When you check indigenous lands that are not or did not get funding from the federal government, at least in the time frame where we analyzed our study, what you see is almost the same, probably actually a bit more carbon storage in this kind of indigenous lands than protected areas. Um, so those were the results in terms of carbon storage. If you check in terms of biodiversity, so I mentioned that we use a composite index that brings richness, rarity, and intactness together. And in this case, the indigenous-led nature-based solutions that got funding from the government have very similar outcomes in terms of biodiversity when you compare them to protected areas. When you have indigenous lands that were not funded by the federal government, that is also the case. So it's a very, very similar. So at least so far, we can say that indigenous-led nature-based solutions are as effective as protected areas in terms of biodiversity and carbon storage. That means climate change mitigation. We also try to see, and there was something very interesting that came from this analysis. We try to see not only like the total amount of carbon storage, how similar it was in indigenous lands compared to protected areas, but we also wanted to see after government funding is started, we wanted to see if there was like some effect from that funding. So we did our best to control for different compounding factors, as I mentioned, and so what we were trying to see is if did carbon or land use emissions were they different before and after funding? So, or was biodiversity different before and after funding? So what you're seeing first are the results in terms of biodiversity. So both protected areas and indigenous lands did not show a clear signal of change before and after funding. Um, so that's the case of the comparison of indigenous lands that were funded by the government relative to protected areas. When you see indigenous lands that got no funding relative to protected areas, you see a similar result. So we were not able to actually see differences before and after government funding in terms of biodiversity. But then when you check land use emissions, so imagine emissions that might come from deforestation or forest fires and similar like land use pressures. So what we saw is that actually there were higher emissions inside protected areas before government funding relative to indigenous lands that eventually would get funding. But what it's interesting is that, yes, both indigenous lands that got funding from the government and their like counterfactual protected areas, they had carbon losses, but the carbon losses or land use emissions, they were lower in the indigenous lands that got funding. So we could call that avoided land use emissions. There were less emissions in indigenous lands that got funding from the government. In other words, indigenous-led nature-based solutions compared to protected areas. And what it's interesting is that when you do the same comparison, but between indigenous lands that got no funding and protected areas, what you see is that actually there was not so much change between the pre-funding period and the post-funding period. Probably there were like slightly higher gains of carbon storage in protected areas, and indigenous lands were very stable. We did not see such a clear effect in that case. So our conclusion about this is that government funding has is related to moderate but statistically significant avoided land use emissions that you don't see when you compare indigenous lands that got no funding and protected areas. So to finish, so I have like three key messages, and I would like to just explore with you like three, like some consequences of those key messages, some implications. So the first is that, so we can say that indigenous-led nature-based solutions, they can be as effective in terms of climate change mitigation and biodiversity conservation if you compare them to protected areas, federal or provincial. So these are not news, but these results contribute to the accumulating literature that says that you don't need fortress conservation approaches, conservation without people, to achieve environmental outcomes. Evidently, where do these results come from? From indigenous-led nature-based solutions? They come from traditional law knowledge. They come from customary laws, from place-based values. Are the ones that actually contribute to these results, and so we could frame indigenous-led nature-based solutions as some kind of alternative or special kind of nature-based solutions, which is not centered only around humans, but it prioritizes reciprocal relations between people, nature, and living and non-living entities. So that's what is, I think, different from indigenous-led nature-based solutions. Then we can say like government support can have immediate effects based on our results, but there's some caveats here. For instance, the projects we analyze, most of them are only funded for a year, so very short-term funding. And another key challenge is that many indigenous lands, they are experiencing like difficulties because of land rights. If indigenous peoples don't have full recognition of their land rights, it's hard to execute land or stewardship and achieve environmental and social outcomes in the long term. So these kind of results that we are seeing are very positive, but there's no clear recognition of indigenous rights, including land rights. Like these outcomes cannot be guaranteed in the long term. And finally, indigenous jurisdiction is not only about lands and waters, but we also need to think about the digital age. And so, for instance, we need to think about the role of this kind of data in terms of governance. So there should be like protocols and standards in place that guarantee that indigenous peoples not only have access, but that they have control and ownership of the data that is produced by these kinds of studies. And finally, let's bring also a reflection about like how do we use digital tools. So like there's interesting work at Concordia led by Professor Jason Lewis. So like we have this perspective about using digital tools and individual users, but why don't we think about using AI in a more collective way? Not only AI, but digital tools in general in a more collective way that contributes to sustainability. And we want to bring this kind of example that I brought today to showcase that kind of application that is for collective good and is for sustainability. And that'll be all from me. Thank you so much.
Great, thank you, Camilo. I think we will move right away to the next speaker, Angela Kross, if you're ready to jump in. We will have a question period after this second talk. So if you have questions and they're top of mind right now, feel free to drop them in the chat, and I will circle back to them in the question period. So let's move on. Angela, I'll pass it over to you.
A second. Give me a second, my sharing. Okay, sorry. Okay, sorry. Can you see my screen?
Yes. Yeah, it looks good.
Okay. Thank you, Damon. Thank you, Sarah, Rebecca, Camilo, for inviting me and presenting me. I'm very happy to participate with this event. Sorry, I just have to hide the. Okay. So yeah, so my part will be on remote sensing for nature-based solutions, and I will basically focus on two parts, which is identifying opportunities for implementing nature-based solution, and then also for monitoring ecological outcomes. I will skip this because right now you already learned from Camilo what nature-based solutions are about. So I will kind of go into the part on remote sensing and geospatial technologies. So there are two key questions that are related to nature-based solutions and that kind of are important when we think about using remote sensing. So the first one is where do we implement them, these actions, and how do we verify or monitor that actual ecological benefits are, are being delivered. And I just go here. So it's basically a matter of this example here is just to show that if you think about choosing cities, for example, for urban greening, where would you focus on? Like, how would you know which city needs it more or less? It's just an example of Greater Sudbury with the mines kind of around the city. But then also within a city, how do you decide what you have to, with what location you actually have to choose to focalize your actions on? And then once you have implemented those nature-based solutions, then the next question is, how can you actually verify if there is any kind of impact? This is an example of the loose area in China before and after they actually intensively implemented recovery of the vegetation in this area. Okay, so remote sensing can actually be used in for both questions. So when we look at identifying, so finding out where the graded land is, where there are areas with flood risk, erosion risk, which areas in a city, for example, need more cooling than others, which areas need reforestation or not. So identification is one, and then the second one would be delivering benefits. So you can look at vegetation recovery. How is the vegetation recovering after the implementation? How is the biomass increase, the carbon storage, the cooling effects, biodiversity, etc. And so I want to go through three examples maybe, but I'm aiming to do at least the first one fully, and then I have two others. So the first one would be about using remote sensing and geospatial technologies to assess and monitor urban green spaces and the ecosystem services they apply. So it's about heat islands, cooling effects, and kind of monitoring other ecosystem services that are supplied by vegetation in cities. The second one would be about monitoring biodiversity, and the third one about carbon and plant phenology. So let's start with the first one and see how far we get. So just to rapidly say what it involves when I say remote sensing. So basically in my lab, so the Earth Observation Lab at Concordia, we kind of use all kinds of images, be it drone images or satellite images, ranging from visible light, near infrared light, thermal light, all the way to microwave sensor. So there's a whole range of information that we can collect about the environment and that we can then use to relate to the indicators that we need to monitor impacts from nature-based solutions. Okay, this is another example of that. One important part in the remote sensing application is ground validation data. So whether we look at biomass, carbon, biodiversity, phenology, leaf area index. Many of those models that we develop need validation. So there is a large component, field component, that we have collecting data in the field. But there are also a lot of data that's available online. So there is carbon data available online for flux tower networks. There is a lot of like individual data sets from different efforts on plant biophysical properties. Okay, so the first how can we use remote sensing to assess urban green spaces and ecosystem services? And so this one here is kind of an entry, a paper that that is supposed to come out this year, and I hope, the Next Gen Cities Encyclopedia. Where the example here I'm showing is Ottawa and Montreal, using satellite images to classify high versus low vegetation. So high would be trees, low would be grassland and shrubs. So the darker green would be the trees, the lighter green would be the low vegetation, and then red is urban area, and blue is water. So there are classification algorithms that you can use to identify those classes. And then there are basically, on the literature, there are equations that you can use that should be also validated or kind of updated. But I just created an example here based on some of the published equations converting high and low vegetation into carbon. And that way you can basically monitor across cities how the amount of vegetation is affecting, for example, the carbon storage, and if there is a need to increase that or more if you have like on a certain a goal. So in this case for Ottawa, you can see the carbon storage is 1.2 metric ton, and that is for the area. And then for Montreal, it's less, so 0.891. And this would be just a way to show how, in a kind of very rapid way, by a combination of classifying satellite images, so these were Sentinel images, 10-meter resolution, can be used to monitor carbon storage. And just to keep in mind high and low vegetation, because that is something we will bring to the next example. So this example is from one of my PhD students. So Lingshan Li, she did her PhD with, under supervision of myself, Carly Sitter and Ursula Aker from the biology and engineering departments. And her first paper was about analyzing spatial patterns of urban green infrastructure for urban cooling and social equity. And maybe in this paper, what she kind of was able to answer is, where should trees be planted in a city so that we can enhance cooling and ensure equitable access? And then how can these benefits be monitored? For this study, she used, so satellite data was land surface temperature. So this is the Landsat sensor, which is freely available. And then also a data set from the city, which includes information about high and low. So this data set already has the information available, but if it is not as available, then as you could see from the previous slide, you could create maps with high and low vegetation. That would then be an input for the models that I will show you afterwards. Okay, so just to kind of remind you of how Montreal looks like, and maybe also to see where the vegetation is. So if you know Montreal well, you know the West Island has more of the vegetation, so this area here, versus the east part of the island, and then you have a center part for the Montreal. So in this here, what she then did is kind of Lynchon then created a cooling supply index, which was based on the temperature data. So the satellite images with thermal information. And then mapped by census tracts, summarized by census tracts and by boroughs, the supply of basically, or the cooling supply or potential of each census tract. So the darker colors mean there is a lot of supply. And if you look at this map, it kind of makes sense, right? So where you have the vegetation accumulated, you have a higher supply basically. And so many times studies stop here at, just the supply based on what you have and then continuing from there. But then what Lingshan did in the second part is she developed a cooling demand indicator that was based on not on demand. So some studies develop demand based on like questionnaires with asking people what they actually need in terms of cooling. But this was purely based on kind of physical demand, like the people who need it. And so that group was the elderly, so greater than 65, and children less than 5 years. So then based on that indicator, this is a distribution. So darker colors indicate higher need for cooling because these are the most vulnerable groups when we think about heat waves. So then the mismatch is about where there is a higher supply. So positive value would be the supply is higher than demand, which kind of makes sense again, right? So here in the West Island, a higher supply, basically than the demand. But then you have some kind of areas that have negative values, which are the yellow and reddish areas here, basically, that we basically focus on the need. But this is a bit hard to do the interpretation. So then there is kind of a cluster map here, a hotspot analyzer that shows really hotspots of where there is a need. So this map then can be used to target areas for actual implementing the nature-based solution. So which parts would we start with, right, based on this analysis, based on the supply that is available or is lacking, and based on the need from the population. It would be these locations, so that would be around La Salle. Point Claire is because there is a very high demand there, but there is a lot of supply as well, but the demand is probably higher. And then here you have Montreal North and Pointe-aux-Trembles, Saint Leonard, and I forgot these other ones here. And then another step further then, so this is all about identifying, right, where would you start to implement your nature-based solutions? So here would be equity and access. So what about that? So now you have the supply, you have the demand, but is there equal access to that? And I will just maybe focus on one of them. 1 second, please. Which is this one here. And this is based on, I will look at the one from income. So what it looks at here is, here you have basically on the Y here, you have the mismatch, and on the X, you have the median income. So the problem area, so the low mismatch is actually the supply is lower than demand. And the problem areas that you're looking at are the gray areas. Oh, 1 second. So the gray areas have a low mismatch. So there is the supply is lower than the demand, and there is low income. So those would be all these areas here, those grayish areas. And this kind of gets another dimension to how to choose for, how to identify where there is a need. If you also want to include equity into the whole question about nature-based solution identification of locations. Okay, and then I'm based on the ranking. So if you only would look at supply, and then looking at the lowest to the highest, the bottom lowest supply in terms of the amount of vegetation available, then this is the ranking that you would have with the lowest Montreal S and Leonard, Ville-Marie, up to Montreal North. And then if you look at the mismatch, so where there is a mismatch between the demand and supply, then it kind of changes. And imagine if we start to implement these ones here, with accessibility, then it also changes. So it is not a very straightforward process, but geospatial technologies can greatly support this way of identifying the important areas for implementation. 15, okay. I'm just gonna maybe rapidly go for the biodiversity one, and then if you have any questions about the rest, we can go and look at that. So the monitoring biodiversity using remote sensing. So this was a study that was done by Jennifer with her master's with me. Camilo was also part of the paper and the research that Jennifer did. And it was basically to explore what the opportunities are and the challenges related to predicting tree diversity. There are a lot of studies on using remote sensing for biodiversity, but as I mentioned before, validation is key. And in the study here, we actually noticed, based on over 2,000 validation forest plots, that species richness, which is kind of one of the bigger indicators for vegetation in terms of biodiversity, is not really easy to identify or quantify with remote sensing with images, and it is all based on the actual spectral information that doesn't allow for it. But the advantage was that there are other variables. So percentage of the composition is actually um, detectable using remote sensing data. So in this study, it actually shows, for example, the application where Jennifer kind of looked at percent conifer 1990s to the 2010s, so over a period of 10, 20, 30 years, to see how the composition actually changed. So if you wanted to look at, how your biodiversity is changing over time, then this method can basically be used to track the percentage conifer in this case over time, which is important, I think, in especially wildfire studies where percentage conifer is kind of a key variable for wildfires. There are some other things I have, but I think I will leave it for if you have any questions, because I feel like it will go for 40 minutes or something. Thank you.
All right, thank you, Angela. Yeah, I might have questions for you about some of the stuff you didn't present, but we can always talk about that later as well. So I'll start with a couple of questions for the presenters. But again, if people in the audience would like to ask things, please just either raise your hand if you want to speak, or put the question into the chat and I can direct it to the speakers. Maybe I'll start with a question for Camilo. So I mean, I guess as I was listening to you, this question has come up before, but I was thinking about it again. What is the current state of funding for Indigenous-led NBS, and like, yeah, how do you think we can collectively motivate more funding to be directed towards these types of initiatives?
So I think there has been a decrease for the initiatives I mentioned since the new government started. So there has been a decrease. I think there was some big effort from the previous government in terms of allocating funding. One could say that it's never enough, but one has to recognize that there was a significant effort. And yeah, like for now, that kind of ambitious plan for nature-based solutions, and I guess part of that big umbrella indeed for indigenous-led nature-based solutions, I think we don't have a similar kind of program in place now that compares to that kind of previous initiative. Then talking about the current situation, I think there's no, obviously the federal government plays a key role, but I think provincial and municipal governments can also play a key role in supporting indigenous-led nature-based solutions. Indeed, we have mentioned all the kinds of benefits, and obviously there might be others. I just spoke about biodiversity, and I spoke about climate change mitigation, and so just talking about climate change mitigation that involves that might involve, for instance, carbon credits, for example. But I believe that besides like that those kinds of known ways to fund nature-based solutions, there are some emerging markets. So like it's a possibility to explore, like for instance, biodiversity credits, but we we still have to better understand the consequences of those, and try to see like there. I think in some instances, private partners can also would be willing to fund nature-based solutions, including indigenous-led nature-based solutions. Like I think there is always the need to guarantee that we do not replicate like colonial ways to do environmental initiatives. I think that is a like there needs to be there needs to be some rules in place to respect people's sovereignty and rights, and so like funding, I'm sure that might be welcomed, but those safeguards need to be in place before like exploring or executing even new ways of funding.
Okay. Yeah, good. Thanks. Before actually going to Angela, maybe I'll the follow-up question in the chat from Emma. So yeah, it's about data sharing protocols for indigenous-based nature or indigenous-led nature-based solutions. Whether it's around biodiversity data, species occurrence. So yes, I know there are huge issues with knowledge sovereignty, and wonder how these are addressed and whether there are any. What is the state of debate around indigenous data governance?
Yeah, that's a very good question. Very interesting question. I guess this is an active topic. There is not. I don't think there's an active or there's no like a final solution. That's what I'm trying to say about like data governance issues. Um, like I can maybe suggest to check. There's an interesting initiative called Local Contexts. It's from the US, and they have like developed like some kinds of a standards and like tags, if you want to call it, to data that involves indigenous knowledge to make sure that the data is being protected, that the ownership and access and control of data is like under like I guess part of the indigenous sovereignty. So I think that that's a good example of good practices around indigenous data. If you ask me about like the data we have used in our case, so this is like in terms of biodiversity and carbon storage, like this is just general environmental data. Is It's public. I think where we need to be careful and have been like asked and people have suggested to me and our like our group of researchers involved in this project is around making sure that you are not exposing spatial data about indigenous peoples like publicly, that there needs to be like some kind of protocol in place to make sure that kind of data is not publicly accessible and someone can use it with, I guess, wrong or not so good intentions. So that's what we have, and that's what we have tried to do in our paper. But in this case, we are not using like for biodiversity and for carbon storage. Like that is just data that we created for Health Canada, and it was not coming directly from like indigenous organizations, just to clarify.
Okay, good, thanks. Yeah, so anyone else, please feel free to continue putting questions in the chat. I'll move on to a question for Angela for the moment. So yeah, really nice to see what some of the things you're working on related to this topic. So one thing that comes to mind, like you showed, for example, the example of Montreal as a local or like a regional focus to this type of analysis. I'm wondering what's the scope to kind of expand the spatial scale of this type of analysis? Does it become, what are there data constraints or data availability or processing constraints that would make it like if you wanted to do national analysis or even global, or global in different regions, are there different data or processing constraints that come in that would be that would make that kind of analysis more difficult, or is it just like more time and more number crunching? You can kind of do the same types of exercises.
Well, I think for the supply of cooling, like the cooling supply index, that would be easier to achieve nationally or even globally, because it's really based on Landsat images, and those are available globally from 1980s till now ongoing. And so the thermal data is available. It's 30-meter resolution, so you cannot go higher than that. But that would be definitely possible, and that would already give an indication of where there is a lack of supply. For the demand, that will depend. Like across Canada, that will be easier to do. That is just based on census data. Globally, every location would have to look into how accessible the census data is. It's basically the proportion of people above 65 and 5, but I think would be the general vulnerable age group for heat related incidents. But there could be other variables that have to be defined on other locations. And then so that would be transferable. Looking at high versus low vegetation. So if you basically want to estimate it directly based on the vegetation for some reason, if you don't want to use the satellite images, then the vegetation, well, actually, okay, a practical way would be if someone wants to do it at a high resolution and wants to use vegetation data, because the thermal data is only available at 30 meters, but let's say someone wants to get very detailed information at 5-meter resolution or 3-meter, then you have satellite images at that resolution, and then you could basically use the proportion of high versus low vegetation in the model that is in the paper to look at the cooling supply. So I would say overall for certain parts it's very transferable. For the equity access, that kind of it would depend again on the census data, availability of census data. Across Canada is totally possible. Beyond it, then it depends.
Okay, but I guess a similar question. Like thinking of the different like global data products that already exist for biodiversity or carbon. I mean, many of those are derived from satellite data at some point in the analysis. I wonder if you could kind of comment on some of the potential limitations of those existing global data sets, and because you were talking about kind of validating those at a local level, but like, to what extent is that validation important everywhere, or is it?
I think it's always important to have it in mind. I've always like when certain data sets are derived from satellite images and they don't indicate like the error associated with the calculation, I already feel a bit uncomfortable to use the data. When it's at a very broad scale, so like entire regions or whole countries, then it probably doesn't matter that much because there's already kind of a large variability in that. But if you go like within city scale, then it would be important to look if the data set reports accuracy measurements. I would be worried about because, for example, the biodiversity, there are so many papers that report that it is possible to map species richness. It's very challenging. If you start validating the results, it's really very challenging. So I would be so it depends. For larger projects, I think it's okay. Like if you go into high resolution, then you would want to look for accuracy metrics.
Okay. We're coming up on the top of the hour. I think if anyone has other questions in the audience, please, jump in now or stay silent as you prefer. Maybe I'll put one more question to both Camilo and Angela. This is kind of a sort of a philosophical question in some ways, but in a sense, both of these talks are about like how do we understand and prioritize nature-based solutions, and like where to place them, how effective are they, what can they achieve? And I'm wondering what you think about your role as a researcher and the how important are the judgment calls that you make in the process of going through the data choices and the the choice of what variables to include, the choice of what priorities to include. I mean, there's sort of an implicit prioritization exercise that you go through, I think, when you're just choosing like what to look at and what data products to use. And I'm wondering if you want to reflect on how kind of sensitive the results of the analysis are to those choices that you make along the way. Either whoever wants to. Yeah, go ahead. Angela. You can turn it to Camilo.
I think it falls in the same line as I mentioned. It's the responsibility to be sure that the data has been kind of validated in an appropriate way. So choosing the right data or either that, or whenever you use the approach and you document clearly what the limitations are. So I would use data sets that have clear documentations about the limitations and some error measures, but not just any data set. Because if you use that in your analysis, then it kind of like it sums up, the error sums up, and then it becomes a problem. And also in terms of well, if it's only related to my area for data, that would be the main concern.
Camilo, do you want to have a last word on this before we close for the afternoon?
Yeah, I would add besides like, I guess, transparency in terms of the analysis that you do and acknowledging the limitations. In my ideal world, I would like do local validation of the results that you get, local validation from community actors, from decision makers, to see how feasible or how realistic and how usable they could be. So I guess it's about being like validating, I guess, in two ways. Like, or what do you do? Yeah.
Okay, well, thank you both. We have one last question in the chat. I think we are past time now, so maybe I'll just quickly defer to the organizers to see if we have time to take this question or if we should just close.
We have time. You're more than welcome to.
All right, so yeah, last question. I don't know if either of you have an answer to this, but this is Karen McEwen is asking about what happens when you have different jurisdictions, national jurisdictions that like kind of overlap the same location, and if there's ever conflict, conflict between indigenous nature-based solutions in, for example, Yukon and Alaska and the Gulf Sea, in areas where like Canadian and U.S. jurisdictions would overlap. So I don't know if either of you have any thoughts on that question, but
so like if I think about that's a very interesting question, first of all. So if I think about the data set that we used for our study, there are no indigenous-led nature-based solutions in this kind of borders. They're not. There's an interesting, but also like I guess a worrying case, which is a jurisdictional issue too, but within Canadian borders, if one could say. And it's about the coastal communities of BC. And so I think you're talking about the same country, but there are some jurisdictional issues in terms of traditional and customary land governance, and then you have like the usual activities, extractive activities on the coast, and so obviously like different worldviews, different perspectives, different regulations. And on top of that, like we were talking about, like tankers now probably passing through some of those areas based on the new visions, like federal government vision. So you have like conflicting provincial, indigenous, and federal perspectives around that sense. So all this to say that you don't need to go to another country, but these jurisdictional issues are already in place here in Canada.
All right. Well, thank you, everybody. Thank you, Camilo and Angela, for your presentations. Thank you for the audience for coming. Thank you to Rebecca and Sarah for your organizational prowess in pulling this event together, and also to ForthSpace for, as usual, making these events run so smoothly. So with that, I will close the event and turn it back to our host if there are any last words.
Thank you so much. Thank you once again to everyone who joined us today, all day online. Thank you so much for your time, your questions, and your energy. We're going to go ahead, close up the Zoom and the live stream now, but a quick reminder that this conversation is available on our YouTube channel if you wish to revisit or share it. We ask that you consider joining for the rest of the conference this week. I believe Rebecca just put those links in the chat. So we would hope to see you there, and otherwise we hope to see you at ForthSpace sometime. Thanks so much. Stay warm and have a great afternoon.